Yeah. So we were discussing regarding LLM, right, sir? So LLMs and its working functionality and working method and the flow and what are all what are all things involved in it. So this is the basic thing. Why we need to learn LLM? The first case is why we need to learn LLM. So right now your AI world is completely based on the LLM only. So you're not doing much ML thing. ML thing is only for a selected areas where it only do problem solving and selected data with your selected the results what you are expecting from it. But coming to the LLM, it is not like the rule based thing which I have said yesterday. It will be not like if else thing or if logic kind of thing in a Python. LLM is things that means over the tokens and it will look at the probability between the words and all, and then it will predict the next best word, the next best token. So that is what it will. So if you ask whenever how are you, it will say fine. So to get that fine answer, LLM is following something. Example, you have GPT 5.5, okay, or you have GPT 5.4. So this is the model, LLM model. So this LLM model, so this LLM model, when I ask some question to it, hey, how are you? Hey, how are you? When I ask this question, what happens? It processes this. It will take this question as an input. It will take this question as an input, as an input, and this input will forward to my LLM like token. First, it will do tokenization. First, it will do tokenization. These things are going to be converted as tokenization. Okay, this is the flow, but later after we'll do some input things only. There are many things involved like wrappers, system prompts, many things. Okay, so after this tokenizations, what happens? It will be moving to the your your embeddings. Embeddings is whatever the tokens that is going to converted, it is having token IDs, it is going to do a dense vector kind of thing. So it will be converting everything into the numeric. So after these embeddings, it will go to the transform architectures. Okay, transformer. Here we have different types of transformers again. So these transforms will understand what to be considered. As I said yesterday, say there is a question like I'm going to a bank. Which bank you are going? River Bank or your SDFC Bank? So which bank you are going? So that is what that has to be considered. So in between there is also called attention mechanism, self attention mechanism also there. So this self attention mechanism will understand among the words which is the word is the right word. So there is a cosine similarities also between these embeddings and while it is converting into these words. So cosine similarity means it will look between the words queen, king, okay, man, woman. So if I say between both are same only, it will represent to the only one person. But there should be a a similarity between, right? So there's a question similarity and probability. So always your LLMs will look on this part with this components. So I'll tell complete flow. We'll going to see each one after other for understanding purpose. Let's understand this how this token IDs layer and embedding layer will be added here. The moment the moment tokenizations is given token IDs, the embedding layer will take the token ID and it will embed into a vector. Vector means what again? The numbers 0.12, 0.45, 0.88 in the squared brackets. Okay, so that is embedding vector. Now this embeddings will convert all the tokens into a rich vectors, a meaningful rich vectors. That one will go to the an information to the transformers. As I again repeating the same thing, it will go to the transformers as a positional information. What exactly the positional information means? Whatever the output you have, whatever this output of this embeddings will be going to this transformers in a parallel mode. So your transformers will do everything in the parallel. All tokens will be going to be in the parallel, like position order. So with this said, it can able to understand and then the self attention mechanism can come. So here there are types of things are there. Okay, let me, yeah. So example, if I have token 1, mm, yeah. So if I have token 1, so if I have token 1 as a dog, if I have token 2 bites, if I have token 3 a man. Okay, so I have sentence 1, that is dog biting the man. Sentence 2, I have man bite the dog. Both are similar. Both are similar. In same words, different order, different meaning. So here in the transformers, okay, before it is going to be with your transformers, and the transformer will process all this in parallel and understand that, okay, what is this positional encoding has to work. So now it will understand between these positions of how these sentences are meaning. Okay, so that is the main agenda of this positional information. So this is a positional encoding, we'll say. So let's say there are many things like ably also there, rope also there, if I'm not wrong, positional embeddings also there. So there are different methods we can use. I guess there are four methods are there. Four methods we can use in this process. So you are seeing GPT-4 means how it is acting now. Behind the scene, these many things are involved. While they're doing training, so these many things are involved. Okay. So after this transformers, in transformer block itself, as I said, we have self-attention, residual connections, feed forward network. Like this, I will tell we will do the lab on this transformers, especially with this complete block, so that we will be understanding. Now theoretically it will little bit confuse. So self-attention as I said again, so it will be looking at the previous words which are all I should important to, which are all the words I need to give importance. So if I give like a sentence, a animal didn't cross the road because it was got injured, something like that, then my self attention will only see the previous things. Okay, it has to refer to the animal. So if I ask again in the next sentence, like a road was blocked because of it damaged. So like this. So it has to only understand road. In previous case it is an animal, in this case is a road. So it has to understand which is the important word out of this sentence. So that is what the attention will do. That is what the attention will do. It will trying to find out the best word from your sentence. From your sentence. As we discussed, there is a Q, K, V. Query, key, value. Query is what I am looking for. Key is what information do I contain. V means what actual information that I have. So this is the self-attention thing and the formula. I hope you already went to notes and you seen. Uh, right? Yeah. What what is the token looking for? What I'm looking for? Okay. Whatever. Like your framing is anything like this. So value. What is the token? Contributes. Okay. Or what this value is having over there. And you have different things like feed forward, multi-head attention, layer normalization, residual connections. We'll get into the deeper after this. And there are encodings also. Okay, decoding strategies are there. So we will discuss that. But first of all, I would like to take a pause here and I just wanted to understand. I just wanted to understand what is your understanding on the LLM so far. We have done two classes on LLM introduction only. What is your understanding on LLM? And what are you thinking from your side how this LLM things are working? So would you like to add any new information which I have not provided, or do you want to repeat what I have already said? It's up to you. But can you please let me know, sir, uh, what is your understanding and so far on the LLM?
Prediction, sir. Predicting on what next.
Predictions on what next? Okay. Now, what is LLM means? Whenever someone asks in the interview, we need to say that LLM is that one, this one, and some little bit context and definition, and then how it works and some flow.
So it's a large language module which is trained on huge data,
Hmm.
and whenever the user prompts for a specific query, it will check in the its database and it provides the an answer. So that's my small description about that.
Okay, okay.
Can be elaborated more, but with respect to technical, like as you mentioned, once the user data is inputted, it will be converted as a tokenization.
Hmm.
Each word will be considered as a token, and then the output of that will be inputted to the vectorization. Then it will be the then it will move to transformation or transformer area. So then the output will be visible to the user.
Right, sir. Right, correct. Okay. Um, anyone others? Do you want to say your own answer?
Rajnikant Garu, as yesterday there was a disturbance and I need to rush to the work. Can you just revise whatever we discussed yesterday? Just an
Sure.
overview of it.
Okay. So basically, let's keep it like this. LLM, when I say GPT 2 model or GPT 5 model or 4 model, Sonnet, anything. You take any LLM from Hugging Face. Okay. Large language model, we will always saying that it's trained on the huge data and the model is trained on, we'll say, uh, 70 billion parameters, 7 billion parameters, like this. What exactly when I say 7 billion parameters? Okay, parameters. So we need to understand this because when we do the training and the deployments and LLM operations, we need to understand all this. The parameters word itself will be like it is the a number inside the model that we are adjusting like in the process of training. Okay, so parameters are nothing but a number or a math that inside the uh, model. So whenever we are doing training and all, so it will think the weight between the neural network. So we'll be having a neural network. So in the neural network, it is a weight. So every connection from this point to this point, okay, from this point to this point, so the connections our neurons has some weights. It is having some weight. So this weight, there are millions and billions of the connections stacked across the layers. So that is what we mean to the parameter. So when I say 7 billion parameter models, example like 5.2, Llama 70 billion or 175 billion parameters models, GPT-3 model, like that. That means model is having many individual numerical values. Numerical values means weights. Numerical values means weights. Example of the weight. Weight 1 is my age. Weight 2 is my location. Weight 3 is my company. So now these three weights LLM will process. Okay, LLM will process. So whenever I say these weights, that is the behavior of my LLM. When I say 7 billion or a 70 billion, that is the room of my model is having all context knowledge. Means context knowledge in the sense it is having that pattern it got learned can able to give you the better answer on this. So far all these models are the text LLMs models only, right? All are text based thing. Similar way we have an images, similar way we have on the audio, similar way we have on the doc side. So similar way we have many areas these LLMs are already there. So how we'll going to calculate this LLM? We call model capacity. Model capacity. Model capacity means more parameters, more capacity to store the patterns. More capacity to store the patterns. And and the relationship also will be good. So this is where it turns from your training data. From your training data. Okay. So that is how your model has more slots to encode and more things to understand what it has is doing. So what exactly happens in the training process of an LLM? When when I have some domain data, I feed the tons of text, trillions of tokens for large LLMs. Okay, if I take any big LLM, trillions of tokens or data or text. Maybe it can be website, scraping website, crawling website information. I store into a somewhere by already converting into the vector, or maybe I'll keep it somewhere like that. Docs, images, anything. I'll keep it all this data and then I'll start giving to my model to make the predictions. So when it is doing, we will be calculating and comparing the predictions versus actual value. Predictions versus actual value. You will get error. You will get error. Okay, consider this error, and you also go and check this back propagations of your gradients. Like yesterday also I mentioned, like gradient means what? How much the each of the billions of the parameters are contributed over the error. In your GPU side, it can able to understand easily. So what we do? We do optimizer. So there is a two things, Adam, SSD, something there. I'll come to that. So we'll use optimizer and we'll repeat again the same process. So that is what the training happens, and we have to write a pipeline. Maybe we have to see the flow, taking an LLM, and then we need to do the same process. Okay, like how companies are doing. Similar way we can do with our one data, and we can practice our lab also. So we will get more understanding on it. Okay, why I have to learn this as I'm an AI/ML engineer or a platform AI/ML operation guy? Why I am learning all these components and the flow, this background, everything? You might be going to be a guy who are going to actively work on inference. Maybe you're going to work on the distributed training process. Maybe you're going to write the automations and the pipelines for LLM fine tunings and trainings. Okay, deploying them into a GPU server side, and you are the person who set up all these expositions, APIs, this complete inference process, everything. So when you are the person, you deploy this LLM, okay, and data science engineer is doing his R&D on the LLM part. That's fine. He is having all uh, the research and development things are done. Then what next? What next? Who is the person going to be involved? What happens? He can just done in the notebook. He'll just get it done everything in the notebook. He'll just say that model is able to have this things, and it is able to create this many, means he check all the checkpoints. He'll have all adapter checkpoints and artifact everything, and then he will say that what is the next. So you are the person is going to involve over there to take that all the outputs, whatever it is, all the outputs, and you have to automate with an infrastructure. You need to set up an infrastructure for that and deploy the production level systems. You are the person have to create it. If already things are getting created, you are the person to deal with all the things components already created. So the every time your model is having these many parameters, right? So each parameter is typically going with the 2 to 4 bytes. 2 to 4 bytes. Like you would say memory, you would say that this will be a memory footprints also. Yeah. And there is F16, F32 kind of thing for your billion parameters models. So you need to also consider this. Sorry to mention, you need to also consider this. You need to have this knowledge whenever you're selecting any model, how much the model need the GB, how much you need to hold on the GPU side or a CPU side to hold on the weights, and which is the optimizer state you have to use. Okay, so this is the knowledge you need, because it ultimately going to run on the VRAM only when you do training. Even though in the inference side it's okay, but your training things will need more than the inferences. So that's what this parameter word meaning a lot. Whenever I say LLM 7B parameters, means somebody has already done all this for us. They given a good room to us. 7 billion parameter good room to us. with this room, with this model, I will put my domain data. I'll put my domain data and I'll do the same process again. Here, I'll only take the model capabilities, but infrastructure is mine. Training is mine, and just judging it, the model is mine. And then I'll deploy the model is mine. So complete things I'll see. Then I will, if it is not working properly, I'll retrain the process, fine tune the process every time. That is again an iterations. Okay. So this is what we need to know. And coming to the compute part, when I say a billions of the parameter models required GPU, so we should go with GPU fleet or GPU, multi-node GPU, single node GPU, whatever. We should have this tensor parallelism or pipeline parallelism concept. Okay, I'll tell GPU things in separately in one or two classes. So that is what we need to consider when we are deploying these models in our organization. Are we good enough to go and avail the GPUs and able to run, or you should go and try it out with your run pod, run pod and vast AI. Something alternative. Something like this. Okay, sorry, I forgot that site name. Okay, so run pod, where we will take the rent of the GPUs and we will do training on it, and the cloud level also you can take, or outside also you can take. So we'll take example, it is going to charge very less to us, very less. So the same server, if you are going to take on the Amazon or if you're going to take on the Azure, there, I don't know, the pricing could little high over there, but it is very less. But you can just create the things and you can run. Then you'll get the result, and that results you can go and create your own servers in the cloud, and then you can do. So most few of the startup companies who they want only R&D, they can do like this as a developer cloud for your GPU things. Otherwise, you can create one server and then there you can practice the things. But selecting the server is matter. Selecting the server is matter. So when I say tensor, when I say you need to have the parallel things, what does mean by tensors? What does mean by, these are all technical terms, sir. I was saying, what does mean by tensors? Any idea, sir? Tensor means what? Or tensors? People will word in different way. Tensors or tensors.
Is it a mathematical object?
Mathematical object, no, no. It's just like, I will say, it's kind of a fancy word actually. It's kind of a fancy word. How means, example I'll tell you. So you have a word for multi-dimensional array in the numbers, like scalar. Let's say, okay. What is scalar? Uh, Scalar, I guess, yeah, it's a single number thing. Okay, which is, we represent OD, I guess, yeah. OD 10 means, sorry, 0D tensor, zero dimension. Second thing is vector.
That is one dimension, right?
This is one dimension tensor. This is for, yeah, vector is a list of things, right? We'll do like this. We'll do 0 point something something like this, and we'll close it, right? So this is list of numbers, which is going to be 1D. 1D. And there is tensor, and between something is I'm missing. Scala, vector, tensors.
Maybe matrix,
1D,
2D matrix.
2D, yeah, 2D matrix, yeah, right, matrix. So it will be again a grid. Matrix is nothing but a grid. So grid of numbers,
Rows and columns. Right?
right? So we also have maths in our 8th class or 9th class, right? So same way, it will be having 2D vectors, 2D tensors, okay, and tensors again. So it is nothing but anything, anything in 3D or higher, I would say. So this is going to be tensor. So what it will be, whenever you are having your deep learning tensors, like you do TensorFlow, PyTorch, all this already exist already to do fast mathematical things on the GPU. We'll come to the GPU, TPU, NPU, APU also we'll discuss. That is also important. I think we should start that one to understand what is CPU, GPU, TPU, NPU, APU, accelerated GPU things. And yeah, so this is what it will be. And gradients. Gradients. So example, when I have weight, the weight is how much the error changes happen on the which direction. When I'm doing some training on my GPU with this LLM, how can I tell what exactly gradient means? Okay, example, you are going on the some hill climbing on where snow is there. Example, okay, and you are climbing on the snow hill, and all of the sudden the sliding is happen and you're going to hit on the ground from the top to down. So but while you're going to reach, but you're not reached at all, but you can feel that what is the depth under your feet, and you can feel that it is going to be hit, and what is the distance and other things there, right? So that is gradient in GPU. That is gradient in the GPU. So that means you are able to calculate the error change, the point where you are, and the depth under your feet, and you're going to hit that. You didn't hit, you didn't had good mathematics there, but your mind automatically calculates in everything over there and tells you that, so this is what you are feeling, you are going to be hit it, or you're going to be reach that point. That is gradient in your mind. That is we call gradient. That is also happens at the at our GPU. So
Uh, Rajnikant, there was that indicates nothing but the source and as well as the destination points, if I'm not wrong.
yeah, source and destination point, it is that is fine, but while your model is training on the GPU's part, in the GPU's part, how machine should know about it and what terminology we call it. So that terminology is called gradients. Okay.
Thank you.
Yeah, so nothing but the slope is nothing but a gradient here. So which will tells that the direction. So the direction is which direction it is. Okay. So that is what the thing, like forward pass, compute loss, back propagations, optimizers, all these are the things inside this gradient terminologies. Okay, this is what some technical terminologies, and one more terminology is called optimizer. Optimizer again, we use I use also like all this SDF and ADAMS and all. What this optimizer will be doing, one of the optimizer you can select as an ADAM maybe. Okay, so ADAM can be decided to use the your gradient up to date or updating the weights, up to date or updating the weights. So you can have the good a smarter optimizer while you are running in the memory process, like you can calculate the momentum and variances and all. So this is the thing. So in order to show this kind of things, I have to have a GPU server, then I have to run this, show this all. We'll try with GPU in the collab, or maybe I'll try somewhere. If not, just understand this. This is what it will be in the GPU side while you're doing training, while you're doing LLM operations, platform operations. So these are the concepts. These are the some of the technical words. In interview, they're gonna ask LLM means not only this one, LLM means these many things are involved. So they might be asking you, okay, you have an LLM, your data science team is giving you the data, he did training. What you are doing, what your part is. You are an AI platform engineer, an AI ML engineer, a staff engineer, or a senior software engineer. What is your work? What you will do? AI means all not always the GPT model. You take the API and creating a wrappers for the agents. No, some companies they do their own development because they don't want to go with the providers. They just want their own. Example: there's a one bank. They have their mortgage loan with them, or maybe they have the customer data, churn and unchurned data, and they just wanted to do text model LLM thing. How? What they have to do? So they have two options. Either they can take LLM and pay to them, or they can train their own model and then they'll keep it inside for internal use. Which one will be the better? So it's up to their call. They have to see the value in it. If it is valued internally to use or externally to use, we can go for it. So that's how these GPTs and big models came, and they made very good money, and they are also running many data centers like this and all. So that is the generation will go like this only. We can't change. Every time some development will come, and there is some target user will be there to use it. We are might be not using, but there will be a target user always. So they will use, and things will get created like that, and it will go like that. And after some time, eventually, when the value is created, we are also going to adapt to it. So the adaptation will start like this. The same case happened with all the LLMs. Now in the starting of the case, Llama models and Llama when created, you and me didn't downloaded any model in our laptop. But companies started downloading those models and putting into their companies, and they tried something. Even there is no value they seen. I've seen personally companies, they said like, why are we need these models. What we do with these models when everything is there already, tools. Still, Llama models are created a values over the period. So they created a room for the innovations and new practice, new things, new training things. Then the things get sorted and LLMs become too popular just in 1 or 2 3 years only. So that's the thing. When someone will ask on this LLM, so we should answer all these things in a very shortcut mode, not in a very lengthy or in a confused manner. In a very shortcut mode, we can say that. So this is a flow. This is what I do on the training part. When I'm doing this training part, these are the terminologies. These are all the keywords that your answer should contain. Your answer should contain what you have done on LLM, what you have done on LLM ops. When a question comes like this, you have to take at least 1 or 2 minutes to describe your work. So, and by including all these terminologies, then okay, opposite person will get to know that, oh yes, he's having good knowledge, good hands-on. Even though he is having not answer, but is having good knowledge on the or commanding on the concept. So that is my main agenda. And coming to the CPUs and GPUs things. CPUs and GPUs thing. Yeah, this one. Okay. Hmm. So there are four things actually. Okay. CPU is a central process unit. We know already what is this, how it will be and all. Okay. And GPU also we know that graphical processing unit. And TPU, someone's so far you not heard about it. Maybe it is a tensor processing unit from the Google. Google is a maintainer now for deep learning matrix math things which we have just learned. You can see. And NPU is a neural net or a neural processing unit. So it is the fastest one for your AI inferences. Okay. Now, how exactly and what exactly these things are doing and why we are using them and how to select them also. So whenever I'm doing a small machine learning models, statistical models, convention models, maybe um, any general purpose task, when I'm performing any machine learning models, my central processing unit is best because it will do sequential process. So sequential process, it will handle one task at a time only, but it will do in a speedy manner. One task in one time in a speedy manner. But now modern CPUs can also do the parallel task nowadays. Okay, still, but we'll see some there is a gap. Coming to the GPU. So whenever GPU is the terminology when you have heard, it will do a parallel processing. You give multiple things because it is having many cores in it. So it will do parallel processing of the task for the better throughput and the better speed. Example, previously it was used for the video and graphic rendering things with the large data sets simultaneously. But now it is become very famous for our AI and LLM model trainings process because we need parallel processing. As I said, distributed, parallel, tensor parallel things and all we need, right? So parallel processing it is need so that the speed will be more. Coming to TPU, it's in a deep learning for the training and inference process. It will utilize the low power and best output. So low power, low memory kind of thing and give you the best output. So that's why TPUs are the matter. That's why TPUs are matter. And NPU. NPU also same. So it use a less power, less latency, and you can get a good output with your model while you're doing AI inferences. So that is why NPUs will be selected. And APU is also there. So who are the vendors are doing this all? So there are some vendors already for this. For TPU, we have Google Cloud TPU because Google is doing this AI computing and everything, right? And there are this companies called Apple also there. Apple also doing this M1, M2 chips with that, and some other companies also there. I forgot like AMD also there, Ryzen also there, and some other companies they're processing on the chip processes. They are okay for their laptop things and all, but coming to the AI models, LLM models to be deployed and see their things, how things get created, uh, learned for the deep learning training model and all. So NVIDIA is the best on the GPU side. So this is what GPU, CPU, TPU, NPU will look like. So the same thing I have kept here. So few powerful cores For what it will be doing? For GPU means what? And TPU means what? Why we use it? And NPU means what? Where we use it. So we use it at phone features, camera AI, speech recognition, translation. As I said, Apple also, and recently many mobiles are using this AI, right? And them like images, when you do the capture, it is adding those things and all. NPU is the best chip for the mobiles. When to choose which chip is up to us. So this is difference between CPU, GPU and NPU. Which one we are going to use? So your organization will take the take on this, which they have to use GPU, TPU, NPU. If you are in the Google project, you must go with the TPU and NPU. You are on other projects, maybe you're going with the GPUs only. Okay, you will be not going with TPUs and NPU. Most of the cases, CPU, GPU can do all your job. Most of the cases. If not, you are going with high deep learned model and like you are having a bigger picture, then you can go with the TPUs and NPU. Okay, so that is the broader understanding about this TPUs and GPUs and all. So GPUs, however, is important. TPUs, however, it is important. I will tell when we are doing a model training, LLM model training. What is a pipeline? What is my pipeline for LLM model training? How it look like? What a data science engineer is going to ask you, and what you have to provide to him. Where are the areas in left and right? Things will be associated with it, and the outputs, which outputs and types of the outputs I need to take them and deploy where. You deploy where? In the GPU. In how? Two things: training and also inference. Where you do the serving things, and Kubernetes or where, and what are the serving stacks are there, like Tensor, vLLM, Triton, TGI. You have many things. Which one you're going to prefer? So this is a thing we need to learn in two parts. One is one is CT of LLM, okay, fine tuning of an LLM, okay, and deployment of an LLM. This is fine. Continuous training on an LLM and fine tuning an LLM, deploying an LLM. Okay, we'll see this benchmarking and things and later. Okay, but your fine tuning is very important. Continuous training and fine tuning and deployment. So this is what we have to learn on the LLM. And the deployment part, once you deployed, serving, inference, inference of a LLM. How the inference should come to your an LLM model, how your LLM will give you the answer. Where, which area, which cloud, what resource, what infra will create, what happens from the users things. Okay, so when your data science engineer is here, so we'll just give the notebook, just give the notebook. So most of the organizations, data science engineer is there, right? So he'll still be on the notebook only, and things are getting automated like this. Still they'll just run it, and they have something to upload into the S3. From there they will take and they'll go with the deployment process. But no, not like that. So some organizations will follow complete process of how these DevOps things will work. Similar way. So this is what I would like to give you a bigger picture. Why we are learning LLM? What is the business problem here? Every organization is having their own business problems. Companies, few companies only they are doing LLM operations. Not every company. The company who are building their product, they are the one who are doing LLMs. Other companies are not doing. Example, if there is a company, they want to sell a specific domain knowledge AI to the target users. They train the LLM. Can be in insurance, pharma, medical, banking, uh, entertainment, this side. Okay. LLMs is needed for a specific target users, domain specific. Yeah, they will train on this LLM. They'll take one LLM and they feed the data and they'll get it done like this. Second part is every company is doing. So second question is every company, no. Few companies who really wants to develop their model because they wanted to create their model to be private and they want their own value to be show to the target users. The one more type of companies already LLMs are there like GPT 5.5, Claude Sonnets, Opus, DeepSeek, Gemini. Already LLMs are there. Why we need to create our own LLMs again by doing the trainings and all, the deploying and all? We don't have much bandwidth. So they'll take the API keys of those existing models, providers models like Cloud Code and all. API key they will take and then they will write the wrappers like Crew AI agents. They can write the agents or wrappers. Crew AI, LangChain, LangGraph. You can use AutoMN and all. Otherwise, directly create your own wrapper and set it to your API key. What API key, where it has to invoke and all. And then how you wanted to see the results from that model. You can create entire wrappers and entire application for that API key. And that model will give you the response to you. So this is what companies do. And this is what they're selling. Even you and me can also do. If you have good idea, tell me, sir. We'll just buy one API key. We can try to implement something.
Rajini, in my company, they are using few GPT models. So how they can integrate with our business? I mean, the company business, because that is trained on few different data, right? Whether it has all that kinds of data even for the company. I mean, when you talk about company, general data.
So, sir, last line I have missed. Last
No,
line, you are
in my
audible.
company, they are using a few GPT models.
Hmm.
So why? I mean, their business is different. But if they are consuming the different models which are developed by GPT or Llama or Google, so how they can integrate with in their organization, and how it can give the result, because they have their own set of data, they have their own business. Maybe if you take a small business like logistic or transport business, sales or supply chain, so how they can use those models which are already developed and used in the public.
Okay, so every company is having their own private data. If I summarize your question, private data, how can I believe that and keeping this data to the public models like GPT-4
Yeah,
or GPT-5? So that is not the good one. Right. So to answer your question, example, I'll just take two, three examples and I'll try to. Yes, we not completely paste the complete private data. What we will do, we'll do You know, right? RAG thing. RAG is there. RAG and MCPs.
Yeah, okay, I
Both we
got it.
will use.
Yes.
Okay,
They are using that one correctly.
right. So RAG is a retrieval augment things. What it will be doing, we build our own RAG system. The data with us only. Vectors with us only. Everything with us only. So in this thing, we only use LLM capabilities, like GPT capabilities we'll use over there. Okay, this has to be answered like this. This has to be answered like this. But the data will not directly go to the GPT side. No, they don't have that much. We only use the capabilities of the GPTs. So that is what we do, the data control. Okay,
So
and
will you
MCPs.
be showing this setup in
Yes,
this
yes.
training, because that is where we need that is an enterprise deployment what as of now in my organization they are doing.
Hmm.
So just wanted to understand that flow so that I can get hold of that
No, no, no.
workflow.
I will show RAG, MCP because these are the things that we makes and private, right? So
Hmm, hmm.
MCP is the one thing that we will connect on our own, and also RAG is the one thing that we'll keep everything in our network, and then we only connect AI model to it. Okay, so
Okay.
that's what. So I will show all this actually how to create RAG thing, what is our own data, and how to mitigate them not using as a public things, where we'll write all the guardrails also, that should not be like this and this should be like this. So we cannot send example. I will tell, if I keep a GPT-5 model in the banking in your model only, so whenever the input data is coming, when the input data is coming, they will enter the account number. But see, account number they have entered, will the ChatGPT will take that account number? No, since you have written a wrapper over there, the account number will automatically mask, eradicate over there. That is a guardrail will keep it. So when it account number kind of thing in the prompt it come, immediately it will mask it, and then it will send that information to the LLM. Then LLM and your will call your RAG. In the RAG, it is able to find out all the relatable search, and then it will build a context. That context go to the LLM. LLM will give you the proper fine-tuned answer, and that answer you will take it, and you will again validate through your responsible AI or output layer or your response layer AI with some small SLM model, and then you can post that output into the user side. That's how it will done.
Okay.
Okay, so we'll write
Oh,
always, yeah.
Rajni, so you said like if we give account number and it will not take because a wrapper, but there is some talks are also going like data privacy, like DeepSeek. If we are using DeepSeek, then China also taking our data. So how is it working there?
Sir, thing is like DeepSeek, when you say DeepSeek, when you say it's a public model, they release this model to collect the data only. So if we are using the DeepSeek, then it's our mistake. So what we don't know what how in which type they are collecting the data. So there are many complaints that from the Anthropic that China is uh, decoding the models of their Anthropic models and they are trying to build something. See, a similar way. So DeepSeek can be also collected. Example, I'll tell you. If you wanted to use DeepSeek in your mobile, you have to download the application. What they are asking in, and it is also free. What they are asking you just number and email, and it is free. And they are asking also something and ODB something like that. So they're taking your number. Ultimately, they're taking your number. We don't know what China is building by collecting this data. So similar way, if you type any prompt in the chat GPT or anywhere, we can see that. DeepSeek also can see that. ChatGPT also can see that. If I'm using GPT in my company or in your company, you wanted to create any wrappers, still I can build a system to see your prompt, and I can see the system which is also the response given to you by the GPT model. So everything will be tracked and we can able to see. But to hide the sensitive information, we can write guardrails, policy checks, and sensitive information hiding kind of things. Guardrails we can write over there. With that, it will be not leaked sensitive information. It will be cut off over there in the first input prompt only. It will never process for the next onwards. So when you talk about the DeepSeek, it's a public based model, sir. It's our mistake that to use the DeepSeek if they are collecting. We don't know they are collecting or not. But if we keep your sensitive information in the DeepSeek, it is public. It is going to be to the DeepSeek, however. So this is, however, yes, the leak is there. They will collect the data. It's a thing is already there in the market. If you ask me, GPT and Anthropic, they are also collecting our data, but they follow the rules and norms and some things like they're not like this Chinese people. They also collect, but they have some ethics. So that's the only difference between these models.
And what is guardrail? You're telling?
Okay. So guardrail is nothing but, sir. So whenever I'm typing any prompt in my chat GPT, example, you given your all your account number, password, and everything, and you say the chat GPT that, hey, can you uh, tell me what is my account bank balance or something like that you say. Or whenever you give API keys of your companies and or maybe any passwords into the chat GPT will never print back to you again. You try, say a password or something and ask to print back that password. It will never print. Why? Because in input stage, the moment you hit enter, the prompt is going to process in the next step, and the next step there's a guardrail. It will look at your prompt is having any sensitive information like password, API key. It is there. Immediately it will mask it. Immediately it will mask it. And it will mask it and then it will send some fake or dummy data in the next process to the LLM. And LLM is actually receiving a fake data in the place of your sensitive information. Then LLM will give the answer back to you. When it is written back to the answer to your user question, so it is not having key, right? Ultimately, it will not print that key. So that is guardrail, sir. You getting me, sir?
Rajnikant garu,
Mhm.
hello.
Yes, sir.
Yeah. Normally, what I see and I've seen in the past also, uh, the colleges basically, the then standard school students as well. Like the same student cannot study in multiple schools, right? But all these schools publish saying that this candidate studied in my school or college and acquired a very good rank for marketing purpose. So here there is a data leak, right? From one school to another school or from one college to another college. How we can stop this?
We can't stop anything, sir. I mean, it's a data is in public. There are
Mm.
many agencies who
Mm.
companies, the data sharing companies who live in this leakage, data leakage thing only. For example, any Google. Let's take an example. Google only. Google
Mm.
itself is selling our data.
Right, right, right.
So you can buy the Google API for your ads or something like that.
Mm.
Then you have Google that Google will give us our all data, but not everything. Just some minimal data only it will give. It is there like that. There are many agencies are already there. Companies, big companies who give the data which they collect from the different sources and they process and they sell it to the targeted customers.
Mm.
Example, sir, now I wanted to start one food application.
Right.
Okay.
Mm.
Now, food application, I just wanted to find out the gap. So by seeing in the real time in my according means around my environment, I can feel that oh there is a problem. Maybe I have to create one application. That's fine. Problem and problem statement is clear to me. Second thing is I need to build an LLM model or a application. For that I need some data to do my development. Where can I get that data first of all? Where is my real time data of the users? I can't collect, right? By going on the road, every student or every person, hey, can you fill this form, fill this form? No. What I will be doing is, I will do in three, four strategies. The first strategy is I can use influencer, means influencer
Yes.
people, and
Right.
then in a different way I can strategize and give an advertisement so that people will go and check it over there. That is one method. Second method is where this data is already available. Maybe I'll just try to approach different agencies. Those agencies are already having all this data. They'll sell to me. So I have to buy from them. And then another type is like once I already created one beta application, then
Mhm.
I'll promote and I will throw it on the market. And then people start using. From that onwards, I will collect the feedbacks and then I'll retrain the process. So this is how we collect the data. But data leakage thing, that
Mhm.
the agencies are already there, right? So they will
Right.
sell. Ultimately, for you also,
Mhm.
after a long period, 1 or 2, 3 years, you collected good number of data and you're not having good profits. You thought to sell it, or you thought to someone is going to acquire you, or you thought to stop it. But you wanted to make a cash, right?
Right.
What you'll do with this data? You'll again approach to an agency. Agency will take your data at some cost, or maybe you can some other guy will ask you. You will sell this data automatically. So, but there is a limit. It's not like there should be a process and there's a norms you have to follow. Not every information that you cannot share. That is only minimal information you can share in the data.
But if you say in this way, like every organization is selling their data to
No,
some other
no,
company.
no. So this is where the companies are having certificates. You know, right, sir? This auditing will be go on, and there
Yeah,
should be
yeah,
an
yeah,
ISO
yeah.
standards.
Right.
So, yeah, ISO standards and everything. The company's ISO standards and according, it's following every rule like IT law and ISO standards. The company should not. If it is taking that kind of thing, it will face the legal actions from the government. Especially in the Europe side, if a small policy change they have break, their company is shut down from the government. India
Yeah.
also same thing. So there are some
Yes.
policies.
Right,
Yeah.
sir. I understand the policies in the Western countries or any other part of the India.
Hmm.
But what I've seen in India is, though they are very big people or whatever it is, everything can be sorted out with money if the data leak happens also. Because there was a sudden situation where there was a case on Airtel company that they have sold the data.
Hmm.
There was a case like that as well. So that has been cleared.
Hmm.
So things are happening in the top class companies as well. Airtel is one among them, which I said just now. They are
We are,
selling the data. Without selling the data, they cannot make profits. It's an open secret, I would say.
yeah. We can't change, sir. We are just ants in
Yeah,
front of that big companies. We can't change anything.
right.
So the companies they took, they did. The only thing, so in current world, we need to secure some personal information at uh, at our best. That's it. Other than that, things we cannot control. So that information is however it will flow. Your Instagram, your
Hmm.
Facebook,
Right.
your ChatGPT prompts also. Now ChatGPT started the same thing. What it is doing, it is also promoting ads. On what
Hmm.
basis it is promoting an ads? Based on your prompts.
Hmm.
So it is also having, instead they're selling, they are utilizing it. Ads thing. Meta also doing the same thing. Based on your status that you're seeing and people connected to you, based on it, your voice thinks it will track and it will give you the ads in your status, WhatsApp status.
Right.
So everywhere, it's like that. They will use our data to sell their products. The only thing is some personal information and this money banking, those things only we need to secure. Other information is a very general information. Wherever it go, it will be leaked.
Right, because this I've done a proper research for myself itself, because wherever I do shopping or whatever it is, they collect
Hmm.
the data. If
Hmm.
I do a grocery shopping also, they collect the data.
Yeah.
So what I did is I stopped giving my information, including my name as well as my mobile number as well. If I don't give, they will yeah, not send any kind of saying that any kind of ad to me. So that is what I keep on saying to my other students as well. No, don't share your information to anybody until unless it is required.
Okay. Example, sir, you went to AMB mall, okay,
Mm,
and you did some shopping.
right,
Okay, so there they're going to ask, sir, can you tell me your mobile number, WhatsApp number, so the bill will come to. If you give a wrong mobile number, this is the conditions. If you give the wrong mobile number, the invoice not come to your WhatsApp number. Simple.
right,
Okay,
right,
so you can't exit from there. Maybe okay, the second part, it will come or not come, you can exit. But the thing is, they are collecting your WhatsApp number over there. So
right,
why exactly WhatsApp number? So in this shop guy is integrated with some WhatsApp CRM.
right.
So CRM tools are there like Vati or
Mm,
something like that.
mm, mm,
Vati.ai and business WhatsApp business APIs.
right.
The moment they do that, so there's a CRM system in the shop guy who is took from vendors. It will process and it will generate an invoice and it will send it to your WhatsApp to the CRM. So this your number is already in their database.
Mm,
So why they need means from next onwards to send you the offers. You will not miss.
right.
Okay. You will be not missing their offers and their things and your follow-ups, maybe anything. It's in
Mm,
a different areas. If in my
right,
case, if I take your number, so I can maybe give you reminders on the class joinings. Maybe
right,
I can give you reminders for the payment of paid payment, maybe
right,
EMIs, or
right.
maybe workshops things, or new
Mm,
course I'm going to do. All this I can do since I have all this information in my DB with Excel sheet.
right.
Now, the thing is like these companies who is like the CRM companies are their only dealing of what customer collecting.
Mm,
And in the back end, this Vadi company is having all like let's say they are working for 100 customers.
right.
They are working for 100 customers data with them. 100
Mm,
customers mobile numbers with them.
right,
100 customers locations with them.
right.
So what they will do, it's their call. If any company is going to create, they can sell this data also. Or
Mm,
what they will do instead this, they'll make a cache in two ways. One way is directly sell the data.
mm,
Another way, they'll create an API like Google.
mm,
So the who is another user, example me, I
mm,
want to create a app. I need the customers, e-commerce customers like the shopping customers.
right,
Because in the initial case, I don't know who is the customer and customer also don't know me. But I need to start sending some
right.
promotional messages to you, right? Without
Mm,
your intervention, in your WhatsApp, you receive from Reliance also. Let's say you're not even done any shopping in Reliance, but you got Reliance message on your WhatsApp.
mm,
How it is done means maybe I am the guy. I need to send right
right.
to targeted users in the
Mm,
first promotional things.
mm,
This guy is created an API. I utilize this API into my application. In
right.
this API form, I will buy the data, and this is legal.
Mm,
This is illegal, but this is legal. So people have started doing this.
okay. Even with the UPI also, what we are doing is we are doing the payments wherever we are purchasing something.
Hmm.
automatically our number is captured even there also. That is also kind of a legal thing only, what government is saying.
NPCI is a very strict thing. They will not sell NPCI. I don't have much information, but so far I know that NPCI is very strict. They will not do this kind of thing. Maybe a phone pay, maybe a Paytm. There, those applications will do, not the UPI payment application.
Okay.
Yeah,
And even Amazon is doing the same thing. Amazon Pay.
yeah. So now I think WhatsApp. Yeah. So do you know this information? Kunal Shah. Anyone know Kunal Shah?
Yeah, yeah. I think I heard of this name.
Yeah. Kunal Shah is Cred CEO,
Mhm.
founder.
Yeah,
Cred
yeah,
CEO
yeah.
and founder. Okay. He is now into Meta. There is a
Mhm.
news. Kunal Shah. So this guy, Cred, he
Yeah.
was a Cred CEO and is a good having good thing. Now what was this happening is Meta is took him and he made him a very good deal to improve the WhatsApp UPI payments. And now the thing is he already know how Indian UPI system will work
Right.
completely.
Right.
Credit card system will work. He's
Right.
having the bigger data like PhonePe and all.
Mhm.
It's not that much PhonePe and Google Pay, but he is a competitor to them, almost at least. So that good number of things he's having and he's having good ideas with the making out the credit application is very crazy application in the Indian market. In
Mhm.
just 2, 3, 4 years only, it's become a very good product. So
Right.
they hired him and they wanted to build this WhatsApp UPI things.
Okay.
So nowadays nobody is using WhatsApp UPI, right? So when
Mhm.
you send your QR code to me, I will not send from WhatsApp. I didn't add any account. I'll just fear because WhatsApp is vulnerable. WhatsApp can be attacked. WhatsApp
Right.
can be hacked. How can
It
I
has
trust
been
it?
already hacked a couple of times.
Yeah. So how can I trust it? So I can't
Right.
trust it. So
Mhm.
among the only people, 1% people only using that UPI payment. So that's
Mhm.
the main case. They wanted to expand on the India. They he Meta took Kunal Shah.
No. Okay. I think he'll be earning good income.
So their lives are different, sir. He is in Bangalore. If you go and see the Creda office,
Mm.
super. It's in Bangalore only.
Okay. Thank you, sir.
Yeah. So that's all for today, sir. Let's connect tomorrow with like some practical codes of starting with our notebook, how to load a model from Hugging Face, how to load a model from um, this one. Sorry, load the model from Hugging Face and then do the tokenization and everything. Okay. Yeah.